Okay, so the rational root theorem. It's going to sound kind of weird, but I'll show you how it all works. The rational root theorem states that a rational root of a polynomial equation is in the form p over q, where p is the factor of the constant term and q is the factor of the leading coefficient. So what this one does is, if we have something like this, x to the fourth plus x to the third minus 7x squared minus x plus 6, like, I don't know how to factor that, like, off the top of my head. I can't factor that. So what the rational root theorem does for us is it gives us some choices. It's going to give us a list of numbers where we say, if there's a factor that works, it came from this list. So we don't have to just randomly try numbers to see if they work. We can work off of a list. So here's what we do. The p-value is a factor of the constant term. The constant term is the number without any x's. That's your constant. So my p is going to be factors of 6. So that would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's my p-value. That's the numerator. The q is a factor of the leading coefficient. Well, the leading coefficient is going to be the number in front of the highest power of x. So 1x to the fourth, my q for this one is plus or minus 1. So if that leading coefficient is something besides 1, it's a little bit trickier, and you could have fractions for your roots. So that's where the p's and q's start. Now the first question says, determine all the possible rational roots. Here's how you answer this question, because this question's on your test. You take all of your p's and divide them by your q's. So if I'm dividing everything by plus or minus 1, isn't it still going to be like the same thing? So 1 over 1 plus or minus 1. 2 over 1 plus or minus 2. And the same for 3 and the same for 6. So all of my possible rational roots are these. So basically what that's saying is 8 can't even be a root. So if I was going to randomly guess and check something, don't check 8. Check something from this list and see if they work. Now, how did we check to see if something was a factor? We plugged it in, or we did synthetic division. So that's kind of what we're doing here. It says use synthetic division to determine which of the possible roots are actual roots. Now, back in the day, because I'm so much older than any of you, we didn't have this. We had to do this by hand. We now have a calculator as a tool for us that can help us choose what to work with. So here's what I'm going to do. Grab your calculator. We're going to type this equation into y1. So x to the fourth. My biggest problem is remembering to arrow out of the exponent. Anyone else? Like, you've typed your whole thing and you look back, you're like, crap, it's all in the exponent. So x to the fourth plus x to the third minus 7x squared minus x. So take your time and make sure you enter it correctly. Is that battery dead? Yeah. Great. X. Now, here's something we can do, and I realize you can go to your table and look up the zeros, but here's what I want you to do. Just humor me, because it's going to come in handy. If we go alpha trace gets you this menu with all the y's, and didn't we put ours in y1? So I'm going to pick y1. Here's something cool. When you take this y1 and open the parentheses, whatever number you put in the parentheses, the calculator is going to go plug it into y1 for you. So you don't have to sit here and plug all the numbers in. So you could pick any of these, positive -1, positive -2, and plug any of these in. Let's say I'm going to do 6. You don't even have to close your parentheses. You can be lazy. Is 6 a factor? or is 6 a root? Nope. Let's try negative 6. Well, that one didn't work either. So you can work your way through the list and figure out something that works. Let's try 1, because I happen to know. By the way, if you want to get this same thing over again, do you guys know you can arrow up and highlight it and hit enter, and then you can put a different number in. Another way is you could hit second enter, and it'll pull up the previous thing you typed. So there's 2 ways to grab that. I'm going to try 1 this time. What do you think? We've got a 0. 1 works. So I know right now that 1 is one of my zeros. Woohoo! Now that's going to help me factor this a little bit. Because if 1 is a 0, what's the factor associated with 1? If 1 is a 0, what was the factor it came from? X minus 1. Now, how can I get the rest of this if I know x minus 1 is a factor? Divide. So I'm going to set up my synthetic division. Remember, when you do synthetic division, you divide by the 0. So if x minus 1 is a factor, I'm going to divide by 1. Also, because I made this mistake earlier today, make sure when you write your coefficients that you have a placeholder for every power of x. If it skips one of the powers, you've got to put a 0 there, or else it messes everything up. Alright, so we bring it down, and then we multiply and add. We multiply and we add. We multiply and add. Sorry. We multiply, and no surprise, the remainder is 0. So all of this stuff here represents, what does it represent? X to the third plus 2x squared minus 5x minus 6. I'm not sure I know how to factor this. So maybe I should find another 0. So we already tested out positive 1 and it worked. We know neither of the 6's worked. Shall we try another? Negative 1? Oh, what do you know? Negative 1 works. Put negative 1 there. So now I have x minus 1 and x plus 1. Can I get the rest? By doing division again. So I'm going to do synthetic division on what's left of the previous division. That way my power will keep going down. So this time I'm going to divide by negative 1. I started with an x to the fourth. My first division got me down to x to the third. This one's going to get me down to x squared, and we know what to do once it's x squared. So here goes. We bring it down and we multiply. Add and multiply. Add and multiply and add. There we go. So what does 1, 1, negative 6 represent? X squared plus x minus 6. Now we can continue this process, or can we factor that? I think I know how to factor that. So let's see, I've got x minus 1, x plus 1, and then this one is, what is it? Plus 3 minus 2? Yeah. Sounds good. So I have all my zeros. 1, negative 1, negative 3, positive 2. And those also happen to be the roots. Plus or minus 1, negative 3, and 2. And then these are the factors. I'm going to point that out on every single question because we need to make sure we know the difference between the zeros, the roots, and the factors. If a test asked you for the factors and you wrote down the roots, you wouldn't get full credit. So we want to make sure you know the difference between all of these. There's always someone who says, well, what's the difference between the zeros and the roots? Because they look the same. Was that your question? Okay. The zeros are locations on the graph. So the zeros come from the graph. The roots come from the equation. Because we can have imaginary roots. So some of the roots aren't zeros. Does that make sense? But all the roots come from the equations. We could have imaginary roots, but we can't have imaginary zeros. Does it surprise you that we had 4 roots? No. With an x to the 4th, we expected 4 roots, didn't we? All right, let's try this again. And I realize number 2 can actually be factored. We could actually solve it both ways for practice. But I want to practice this rational root theorem some more, because that's the new thing. All right, does anyone know how to factor this, just for curiosity?
I could do it with a box.
We actually don't even need a box for this one. It says x to the 4th, and that kind of freaks people out. What if it said a squared minus 7a minus 18? Could you factor that?
Yeah.
What would it be?
X
Minus 9 and plus 2?
Yeah.
What's the difference between this one and this one?
Both power of 4.
That's x to the 4th instead of a squared. So this one factors into x squared minus 9, x squared plus 2. So if we had to just factor it, we could. And from here we could get our zeros. We might as well get the zeros, and then we'll check out the rational root theorem here in a second. Zeros. All right, x squared minus 9, how does that one factor? Okay, that's the one everybody should know, the difference of squares. Now, x squared plus 2, can I factor that? No. How can I get a 0 out of that one? We could quadratic formula, or we could just solve it. Can we make x squared plus 2 equal to 0? Your heads are all turned sideways. Here, let me do this so I'm more comfortable and it's straight. Okay. So if I have x squared plus 2 equals 0, what do I do to both sides? Subtract 2. So now x squared equals negative 2. How do I get rid of the squared? Square root. What happens when I take, well, when I write the square root, do you remember we have to do plus or minus? Do you remember that? Every time you write a square root sign in, it's plus or minus. I don't think I'm supposed to leave it like that, though, am I? The square root of negative 2? What do I do with that negative? The I. So x equals plus or minus I root 2. We now have all of our zeros. We have 3 and negative 3, and then we have plus or minus I root 2. And you could write the 3, you could write plus or minus 3. That doesn't bother me at all. Those are the zeros. Oh, would you like to actually see what I wrote? Man, you're demanding. There you go. Sorry about that. Now, here's one where we'd say, okay, those are the zeros. What are the roots? Actually, those are not the zeros. Man. Let's rephrase that. The zeros that would actually show up on your graph are 3 and negative 3. The roots are going to be this. So sorry, guys. Helps if you teach it correctly. Because we can't have imaginary zeros. The zeros have to be real. But the roots come from the equation. Now, how could we have found our roots with this rational root theorem instead of factoring? Because some of you looked at that and you were like, I don't know how to factor x to the 4th. What am I supposed to do here? Well, let's take a look. We would list our p over q's. Remember, p comes from the 18. Q comes from the leading coefficient, which is a 1. So my possible rational roots would be all the factors of 18. And there are just a few of them. So there could be a question on your test that says list all the possible rational roots. And you would list them all. I think your test has some essay questions and some fill in the blanks. There's no submission question this time. My virtual kids couldn't. We had submission problems. So thankful that there's no submissions. Okay, so these are the possible rational roots. If there are rational roots, they come from this list. So that's when you would go to your calculator again. And in y1, you type in x to the 4th minus 7x squared minus 18. And then you just start checking these until you find one. Or, can I look at the table? Yeah. So let me go to the table and notice that, negative 3 works. And then I can keep looking and go, hey, positive 3 works. Which we've already listed over here. We know those were the zeros. So how would I get from here to the factored form if all I knew was that negative 3 and positive 3 were zeros? Well, we would do synthetic division. So negative 3 is a 0. Now this is a good place to remember your placeholders. 1x to the 4th, 0x to the 3rd, negative 7x squared, 0x to the 1st, and negative 18. So we'll do synthetic division, and that gives us, they call it a depressed polynomial. Not because it's sad, just because it's smaller than the previous one. So this is an x to the 4th, so my next line is going to give me an x to the 3rd. So bring down your first one, and then multiply and add. Multiply, whoops, what am I doing? Negative 3 times negative 3. Multiply and add. Multiply and add. Multiply and add. So this one now is x to the 3rd minus 3x squared plus 2x minus 6. And we found out from our calculator that positive 3 was also one of the zeros. So I'm going to divide by positive 3 now. I want to keep getting it down until it's an x squared. Once it's an x squared, I can figure out what to do with it. So bring down the 1, and now we multiply, and we add those together. We multiply, 0 times 3 is 0. And we add those together. We multiply, and we add those together. So now we've got it down to x squared plus 2. So remember our factors from before? X plus 3, x minus 3, x squared plus 2. So that's how we could get our factors using the rational root theorem instead of just using factoring. All right, let's do another practice. I know this is weird. It'll be okay. Yes.
We don't consider the remainder when we divide the synthetic way one more time.
Okay, what did you say about the remainder? I'm sorry, I missed your question.
So like we don't consider the remainder when we divide through the synthetic division one more time.
Yeah, every time we divide, we get a remainder of 0. So we knew it was a root. Is that
But like when we divided one more time with 3, like we didn't consider it.
Oh, so when we divided it by 3, we were just using this part. because the remainder, it would be like we had up here. We had this is a factor, and then this is the x squared plus 2x minus 5, or x to the third plus 2x squared minus 5x minus 6. And the remainder is not even part of it anymore. Yeah. I gotcha. Okay, let's do the rational root theorem here for practice, because it's the new thing. Determine all the possible rational roots. I am almost certain that's a question on your test, so we have to be able to do that correctly. So let's identify all of our possible p-values and all our possible q-values, and we'll answer question A. So remember where the p-values come from? The back. Factors of 12. So we list plus or minus 1, plus or minus 2, 3, 6. I forgot 4. Okay. So there's all of our possible p-values. Now, I gave you a q-value this time that's not a 1, didn't I? It's a 2. So let's list all the factors of 2. Plus or minus 1, plus or minus 2. So when they ask you to list all of the possible rational roots, they want the p over q. So we just take each one of these p-values and divide it by each one of the q-values. So 1 over 1 is 1. 1 over 2 is a half. Then I move to the next number. 2 over 1 is 2. 2 over 2, well, that's 1. And I already wrote a 1, so I don't have to write it again. Let's do the 3. 3 over 1, and then 3 over 2. Then 4 over 1, and 4 over 2. I've already got that, so I don't have to write it again. 6 over 1, and then 6 over 2 is 3, which is already there. 12 over 1, and then 12 over 2 is already listed. So this would be the answer to that question. List all the possible rational roots. So what we're saying is not that every single one of these is a root, but we're saying if there's a root, it's one of these. So just narrowed our list down of what we need to look for. Now, like I said, back in the day, when I was a youngster, we would do synthetic division for every single one of these to figure out which one had a remainder of 0. As you can imagine, this took a lot of paper and a lot of time. But because I have my handy dandy calculator, I'm just going to type, I'm going to go to y1 and type in my new equation. Where is it? 2x to the third minus 9x squared plus x plus 12. So from here, I'm just going to go to my table, and my table is going to help me at least find the first root to get me started. It might even give me more than one. What's going to happen with the table on this one, if 3 over 2 is a root, it's not going to show up on my table. Because what's my table usually count by? 1. If you want your table to count by halves, you can tell it to do that. But those roots aren't going to show up on the table, so we do need this process of synthetic division. So, second table. Do we have a 0? Mine says -1. Just on this screen, I can see -1 and 4. So I'm going to start my list. My zeros, I know that -1 and 4 are both zeros. So let's start there. So I'm going to do synthetic division with -1 and start breaking it down until I can figure out all the answers. I'm going to list the zeros, the roots, and the factors. Just so that we can, just so we can practice distinguishing what means what. So here goes. Synthetic division with -1. So we've got 2x to the third minus 9x squared plus 1x plus 12. All right. Make sure when you're doing this you can read your own writing. For some, I've seen people, they'll write this out and somehow the 1 was too close to this one and they thought it was an 11 and then they messed it up. So make sure you can read your own writing. That's important. Bring down the 2. Multiply. Add them together. Multiply. Add them together. Multiply. Add them together. If you do synthetic division and you don't get a remainder of 0, and your calculator said it was a root, check back with your division, because you should be getting a remainder of 0. Alright, you can write this, because that was x to the third, this is now an x squared, so it's 2x squared minus 11x plus 12. You could go ahead and write that as a quadratic and factor it, but didn't we already know that 4 works?
Yes.
So why don't we just divide by 4, and that'll break it down even further for us. So start right here. Remember, the 0 is not part of this section of the answer. Bring it down, multiply, add, multiply, add.
Wait, shouldn't it be negative 4? I think it should be positive 1 and negative 1, right? Or
The calculator gave me the zeros.
okay.
So negative 1 and 4 are zeros.
So we know for sure, so we don't have to.
So we know that for sure. The factors are going to be x plus 1, x minus 4. So these, if you plug this number in and get 0, it is a 0.
Okay.
The factor is what's going to have the opposite sign. Does that make sense? Alright, so what does the 2 and the negative 3 represent down here? What factor does that represent? 2x minus 3. So what 0 comes from that factor? 3 over 2. So that one wasn't going to show up on my calculator unless you change your how it's counting. So my zeros are negative 1, 4, and 3 over 2. And all of those count as roots. So I was supposed to have 3 roots, and I did. And since they're all real numbers, they count. Factors. A lot of these questions are going to be factor completely. So if I know all of the zeros, I can get all the factors. If negative 1 is a 0, its factor was x plus 1. If 4 is a 0, its factor is x minus 4. And then this one was 2x minus 3. Phew. So that's a lot of work. There's not a ton of these on your test, because this does take a lot of work. And that's with you using your calculator. Imagine my life back when I was your age, and we didn't have the calculator. I mean, we had calculators, we just didn't have this calculator. This calculator was about 10 years after I needed it. Okay, we're going to do one more on the back, and I'm going to have you guys try some. Yay, can't wait. Can sense the excitement in the air. Alright, on the back, I want you to look at number 7. Now, the directions here say determine the zeros. I'm going to change it to determine the roots and factor. Because determine the zeros, you don't have to do any work. They gave you an equation, and according to the rational root theorem, we would have to list all the factors of 42 for our possible roots. There's just a lot of those. But look at the graph. Can the graph help me answer this? Where's my first 0? Negative 6. So negative 6 is a 0. Are there any other zeros? So what does that tell me about my other two roots? They're imaginary. Do you remember that imaginary roots come in pairs? Just like the animals on the ark. This is my 2 because I can't put my finger down. It's kind of funny. No, can't do that either. 2. There we go. 2. Okay, so we know this has 3 roots, and only one of them is real. So 3 roots, 2 must be imaginary. So we're going to practice how to find those. I think we already have, but we'll do it again. So I know -6 is a 0, and I want to factor this. So I need to do division, don't I? Yay! Don't you love synthetic division? Okay, let me ask it this way. If you had to choose synthetic or long division, don't you love synthetic division? Okay. I mean, if you had to choose between synthetic division and ice cream, I'd probably pick ice cream, but still. It's better than long division. Okay, so bring it down, multiply, and add. Multiply, and add. Multiply, and add. There it goes. So if the question asked you to factor, we have our answer. X plus 6 from that -6. And then what's left here is x squared plus 5x plus 7. Can that be factored further? X squared plus 5x plus 7? I don't think so. So if the question said factor, we're done. But we want to find all the roots.
Wait, how come that can't be factored?
There's no factors of 7 that add up to 5. So if I need to find the roots, what can I do with x squared plus 5x plus 7? Yep. X equals -b plus or minus the square root of b squared minus 4ac. Whoops. That's a 7. All over 2a. Let me get my white out so no one gets confused there. So you might want to make sure that formula is somewhere handy when you take your test. You know how you write yourself a study sheet? Do you guys write yourself a study sheet?
Yeah.
It is scientifically proven in the brain, if you handwrite something, you're more likely to remember it. So make yourself a study sheet, because you handwrite stuff, it'll help. Alright, so what does this come out to? -5 plus or minus the square root of 25 minus 28. So -6 was a 0. We have the factored form, and now let's write down the roots. Well, -6 was also a root. And how can I express this as a root? -5 plus or minus I root 3 over 2. So it's a cubic function. It has 3 roots. It turns out that only one of them was real. The other 2 were imaginary. So the real root is a 0, and then we have the factors. So I keep trying to emphasize the difference between zeros, factors, and roots in case you're asked on a test. If you're asked to solve a polynomial for equal to 0, I would list all the roots.
Wait, so when you say imaginary roots come in pairs, do they only always equal one number? Or
yeah, it's always something like this. So earlier we had plus or minus I root 5, or I forget what it was. So yeah, it's always like if you have the quadratic formula, it could be one expression with the plus or minus. Yep. Yes.
I think I forgot, but why did you put the I?
Square root of -3. When you take the square root of a negative, that's what makes it an imaginary number.
Okay.
The square root of -1 is I. So remember, so we could write that as the square root of -1 times the square root of 3. And the square root of -1 is I. And then I squared was equal to -1. Do you remember that? So, important stuff. Alright, I'm going to split you into groups here. If you're on number 6, I changed number 6 because I didn't like my previous one. Okay, so 4, 5, and 6. See if I can put you in 3 big groups. I see. Dave, I'm going to have you with this group of 4. You 4. Okay, you guys can do number 4. Oh wait, okay, so you guys are 6 in the back are going to do number 5. And then you, over your Tiana, Angie, you guys are going to do number 6. Dave, you're number 4. You 6 guys in the back are number 5, and you guys are number 6. Give it a shot.
Like your notes, by the way. No, we're fine.
What the heck? This is like
But you have to get it to a quadratic first. So you have to find some roots, divide it to get a quadratic, and then you can solve it.
Okay, so take 4 and do this with 1 to 4. No, you gotta find the 0,
Whatever those things are called. Gotta find them. Where did I put my work for this? So you can use the table on your calculator to get the first one and then divide and keep going from there. Let's see. Ow.
We're doing the right one. We're doing 5, right?
Oh my god, I'm doing 4.
Yeah, that's what I meant, 'cause I don't want to have to.
Keep using the calculator till it dies completely, then change your batteries.
Zeros are using actually real roots are zeros and just 1. I think you're still recording. I think.
Oh, that's what the recording dot means.
Yeah.
You comfortable?
Alright, so here's number 4. And I'll put this up here so you can take a picture of it if you need to. So for those of you who did number 4, we ended up with our zeros of 4, 1/4, and a half. Now, Shas and I both did the same thing. We got to this 8x squared minus 6x plus 1, and I didn't know if it could be factored, so I didn't even try. And then I did the quadratic formula and went, oh, that could have been factored, because I got the 1/4 and the 1/2. So this time I factored it. And I need to fix this because they're supposed to be 4x minus 1 and 2x minus 1. Oops. So that's number 4. You can copy that if you didn't do number 4. Number 5, I heard you guys talking. I think you got the I root 7 for your imaginaries. So negative 2 worked, 2 worked, and then you ended up with x squared plus 7, which was the imaginary. So for zeros, I just have the plus or minus 2. For roots, I have that and the imaginaries. And then there's my factors. And let's see if I can make all of this show up on the screen. Number 6, the amended version. I found out that negative 1 worked, so I did synthetic division. Now this one, just because I could, I took what was left and I factored it by grouping, because I could continue factoring. And it turned out, because none of these roots were going to show up on my table. The only root that showed up on my table was negative 1. Because the other root was 3/2, and unless you have your table set up to count by halves, you're not going to see that one. And this x squared plus 5 is going to give me imaginary roots, so that, of course, isn't going to show up on the table. Alrighty, like I said, there's not going to be 5 of these on your tests. I think there's 1 that you would have to work all the way through, because they're a little bit involved, aren't they? Just a little bit. And no submission questions on your test. They're all fill in the blank, multiple choice, or essay. So, alrighty.